So this is problem 1.15 for standard 1.2. So it gives you the initial state is psi I equals I over the square root of 3 ket A1 plus the square root of 2/3 ket A2. And the basis for the quantum system is A1, A2, A3. And then it asks you to find the probability that the final state will be 1 over plus I over square root of 3 ket A1 plus 1 over square root of 6 ket A2 plus 1 over square root of 6 ket A3. So the probability of getting psi f with psi I is found by doing that modulus squared. So we need, right now our final state is written as a ket. We want it as a bra, so to do that you just find the conjugate, complex conjugate, which means basically making i's negative. So that becomes 1 minus I over square root of 3, and then the rest don't change because there's no i's in these two terms. And then, so now we have our bra. And so we can then put it into the probability. So we use this, and we put in our psi f and our psi I, and this is what it looks like. And then now it's basically like multiplying a polynomial together. And so you'll multiply this term times that, then this term by that, this term by that, this term by that, this term by that, this term by that. And I kind of skipped a step because when you're multiplying, like when you have an A1 and an A2, that's just going to be 0. And so it's not going to matter what the first part is because you're just multiplying by 0. So anytime the bra and the ket aren't the same, it's going to be 0 because you can't get an input of A1 and get an output of A2. So basically all the terms that don't have the same cancel out, so you're just left with the ones where it's A1 and A1, A2 and A2, and there's no A3 term because there's no A3 in the input. And then, so you're left with this, and so 1 minus I over square root of 3 times I over square root of 3, and then plus 1 over square root of 6 times square root of 2 over 3, and these just are 1, so we can just kind of ignore those almost. And then I multiply them together, and then here you add these, and then square them after finding absolute value, and it turns into the probability of getting this output is 5/9, and that's the end of the problem.